Hi everyone, welcome to my YouTube channel. In this video, we'll be discussing about the CCNP ENCOR. So this is the new playlist I have created for the people who are keep on asking let's do the CCNP so that it will be benefit for them. So I've started for that. Let's get into the chapter of IP packet forwarding. Before that, if you like the channel, do a subscribe button, like the video, and share it with your friends whom you think that it is useful for them. Okay, let's go to the next chapter. IP packet forwarding. So what we are going to discuss about, there are two topics that we will be discussing in this topic. One is the IP forwarding traffic across network devices, that will be explored how switches handle traffic forwarding the layer to frames, and how routers manage to forward the traffic at the layer 3 end. And next we'll be also looking into how forwarding path, how what are the different methods and mechanism that routers and switches use to forward the network traffic efficiently on the network. Let's kick in. So forwarding traffic across the network device is the first topic on this CCNP encode chapter. So the main role of the network is to enable connectivity between the devices. And today, nearly all the networking devices relies on TCP IP protocol rather than the UDP because of the flexibility and end-to-end three-way handshake. And first we have the OSA model, and OSA model then they convert into the like TCP IP model. Our TCP IP aligns with the open system integration model, which consists of 7 layer as illustrated in this figure. In this figure, you can see the OSA model has these 7 layers. In engineering, we would have studied this. And in the right side, we have TCP/IP model also. That the 7 layers has been converted into 4 layers in TCP/IP, and this is widely used in all the network currently, all the network device vendors currently. TCP/IP model. I think hope you guys what are the 7 layers. Physical layer, which is your cable that you are connecting, data link layer where your MAC address will be there, and network layer where we say like IP address transport is for the all the protocols will come. TCP, IP, UDP, and all the protocol will come in transport and session layer, which maintain the session between the two hosts or two end networks. And presentation layer is how do you present the the application. And application, right, the GIF or the word. So those are the applications. So that application in the top layer. So it consists of the 7 layers. When the traffic sends, it encoding from the application, presentation, session, transport, network, data, and physical, and then send it to the one end, and the next end it will again decode in the opposite way from physical, data link, network, transport, session, presentation, and application. This is how the OSI model works. That has been converted to TCP/IP. So it's only 4 layers of works that it will do in TCP/IP. Next is layer 2 forwarding and collision domains. As you are already aware, in the CCNA course, the mostly the layer 2 and collision domains play the main role. We have layer 1 device like hub, and we have switches. So there are different way how the collision domain occurs in the layer 2 networks. So that we'll be discussing now in a quick and short. The data link layer manages addressing below the IP stack to ensure communication is correctly and directed between the host. And Ethernet typically utilize the MAC address that is in the layer 2, or you can say the physical NIC. In your laptop or any hardware devices, even your phone will have the physical NIC. That is where you have the hard-coded address will be there. That is called media access control MAC. While the other data link protocols are those there, which is layer 2, frame relay employ different layer 2 method addressing methods they have. But in Ethernet, because you are using Ethernet, so we use MAC addresses only to identify it. Next, let's talk about the collision domain. Collision domain Ethernet devices employ something called a CSMA bus CD, which means carrier sends multiple access with collision detection to ensure that only one device transmit at a time within a collision domain. This means it can only detect, it won't rectify it. So that's the part of CSMA bus CD in collision domain in Ethernet domain. So device works in half duplex mode, meaning that can either send or receive data at one time. but not both simultaneously. But in case to overcome these, we have something called full duplex that can send and receive traffic simultaneously. Consider you have the device which is sending traffic, and if it is an off duplex, it can either send or it can receive. But in case of full duplex, at a time you can send as well as you can receive. Let's go into detail. The next slide. So here the example for the of duplex Ethernet LAN with hubs. So this is the topology that we'll take up today to explain this. First, an Ethernet hub, a network device used to connect multiple nodes. Consider you have PC1, PC2, and PC3, where we have connected to this hub and operating entirely at the physical layer, at the OSI layer of the model, right? It is under the layer 1 on the OSI model. A hub has multiple ports. Simply what they do is it receive the incoming electrical signals from either one of the port on the hub and reflect to all other ports. It doesn't have any mechanism like how to do the forwarding. It simply says when you say hi, what it will do, if you have 10 ports, it will say hi to all the 10 ports, right? So that's what hub does. So what happened is when let's consider here when you have okay, I have the pen working. So consider the PC1 is sending traffic, okay. At the same time PC3 is also sending traffic, right? So it's an op duplex. So yeah, I can send or receive, right? So this is also sending and this is also sending. What happened, the packet will collide each other. So that time CSMA bar CD kicks in. So what happened when CSA member city kicks in? It hold for some certain time. So then it will again resume the traffic flows sending actually. So again the PC1 and PC3 it will open the ports and then it will start sending the traffic. So that's how the CSMA by CD works in the Ethernet LANs with hub scenarios. And typically this works in the half duplex. Not simultaneously they cannot communicate and they can only one can send in the network and other can receive it. And also one more disadvantage with this, if PC1 is sending traffic, so what happens is PC, if it is sending to, if the traffic is sending to PC1 to PC2, PC3, sorry, and PC3 are supposed to receive, but what happened now, it is an electric signal reflect to all the ports, so it will reflect to PC2 also. So PC2 unnecessarily receive the traffic even it doesn't need it. And next is Ethernet switches, the next level. So this is what the topology that we'll be discussing for the Ethernet switch. As you can see in Ethernet switches, we have all like each port in the switch is a collision domain. So it's a one collision domain, two, three, four, right? So it consider each port in a switch is a collision domain and it operates in the full duplex mode. It operates in the full duplex. It can send and receive at a time because each port in a switch is a collision domain. So LAN switches eliminates the issue of collision entirely, basically, and operating at layer 2 of the OSI model. And hub we discussed it's operate on the layer 1 OSI model. Switches it operates on the layer 2 OSI model. They inspect the Ethernet header and trailer to forward frames appropriately. A key benefit of switches is that all the ports can function in full duplex mode, allowing simultaneous transmission and reception of frames on each port at any time. As a result, the CSMA by CD collision detection mechanism is no longer needed in switches, so it is disabled by default. So there is no CSMA by CD in the switches, and it's disabled by default. So this is what I said. And one more advantage is like switch has a mechanism to forward the traffic in case there are mechanism how it so how switches learns the MAC address that we'll be discussing in the further topics. And if you already have completed your CCNA, might be knowing how the switch learns the MAC address on each port. So switch has the something called MAC address table. What happens is whenever this traffic is coming, it learns the source MAC address here, and then it will save it for certain number of time, and then whenever there is a traffic for that particular MAC, what it will do, it will instead of broadcasting to everyone like hub, it will switch. Consider the PC3 want to send a traffic, the PC1 MAC is already is there in the MAC address table of switches. What it does unicast to PC1 instead of sending the traffic to PC2 or PC4. So that's a very big advantage in switches. uh, Switch Ethernet flooding, right? So first we'll discuss about a traffic is coming and the switch doesn't know where is the destination. I have four PCs as connected here. PC1, PC2, PC3, and PC4 have like AA, BB, CC, and DD. I keep it as simple MAC address so that it's easy for the training for you also to understand. But in production, it's in each PC you'll have like different MAC address. You cannot expect the same MAC address in your PC, right? So let's talk about the unknown unicast flooding. So unknown unicast flooding happens when I connect the switch, PC to the switch, right? Like four or five PCs are connected, and a PC1 want to send to PC2. How unknown unicast is happens? How switch know that PC1 is connected to port 1 and PC2 is connected to port 10? So let's discuss about that. This is we call as unknown unicast flooding. So unknown unicast flooding happens when a packet arrives with a destination MAC address that switch just does not recognize in its MAC address table. So like PC1 is sending traffic to PC2 and it doesn't know where the destination is. I don't know where the destination is, right? Because it's not there in my MAC address table. So in that case, the switch send the packet out of its all the ports. So it will send it to PC3, it will send to PC4 and send it to PC2 as well. The next step is broadcast traffic is meant for all the devices on the LAN. So it's entered to every port on the switch that we discussed. And next, what it does is broadcasts do not pass through L3 boundaries. Routers stop the broadcast and break the broadcast domain. Right. So if you have switches, the switch if a router is connected here from the switch, sorry, then it start depend. Okay. So consider if a router is connected here, right, it stop the broadcast. Basically, router stop the broadcast. It will be in the switches only. So in this case, let's go back to how it identifies. When the request comes, the switches flood the traffic, right, to all the ports. Now the destination is belong to the PC2. So PC2 is reply with this MAC address, right, with the reply packet to the PC1 ARP request. So for the and that time, what will happen? This switch, right, it learns a MAC address of PC2 connected to port 10 and then add it. Consider BBBBB, it's on the port 10 and then send the traffic to PC1. Now, this switch knows the MAC address of PC1, then it's PC2 as well. So when the next time the traffic comes between PC1 to PC2 or PC2 to PC1, it will just do the unicast traffic. It won't broadcast to anyone. That's how the switches do the MAC address learning efficiently. So it's basically, let me repeat again. When the PC sends an ARP request to know the where it arrives on the PC2, the request comes to switch 1 on port 1, and what it does the source MAC learning on the switches. It's always a source MAC learning. So the source MAC has been learned, port 1 AAA, right, and then it broadcasts to frames to all the ports. Then PC2 is replying. Now it is the again the source packet is coming, so it learns the MAC address of PC2, BBB, and 10, and it port number 10 and send it to the PC1 because it already knows where the PC1 relies. Now it won't do broadcast that for the first packet. This packet will be sent only to PC2. So this is how the switch learn the MAC address of all the connected device on the network. Okay, now we talked about the switches and how it learns the MAC address, right? It considered switches like 20 or 30 ports, right? So all consider single broadcast domain. And in order to split that broadcast domain, or like you want to DMZ the traffic of like server, you have some servers connected to the switch, some server users, there are new users are connecting. As a contract employee, you don't want them to connect to your network. So internally, they don't want to you they don't are not supposed to access the network. So that you can do via the virtual LAN, VLAN concepts. Let's go now. So currently I have a server, right? So I have the users in VLAN 10, and I can put them in a two different network in a switch only. I don't have to put them in the same network. But if it is in a switch, there is a problem that people from here they can access say VLAN 20, right? So in this case, now I'm splitting the broadcast domain users in one broadcast domain, and servers are all in the different broadcast domain. So now I can use this virtual LAN VLAN concepts, to split the LAN into different small broadcast domains. This is the actual packet where you have destinations and source, and it uses the by default now, the all the vendors uses 8.802.1q as a standard for the VLAN. So you can see like TP-ID 16-bit, PCP and DE, and VLAN ID is 12-bit actually. So we use this VLAN ID, to split the broadcast domains on a network. Yeah, that's what it says, that a broadcast domain can split into smaller ones with VLANs. By using VLAN, what we can do, a single switch can act as a multiple logical switches and create multiple broadcast domains. This is done by port basis, not by, like, you can do it, but still it's advisable you do it by port if you're a new learner. Next, the VLANs are identified, VLANs are defined in IEEE 802.1q standard, which states that 32 bits are added to the packet header with the following fields: tag TPID, priority code point, and drop eligibility indicator DEI, and VLAN identifier. So basically, what it does on your IP load packet, it just insert a 132-bit field, 132-bit, and it uses this information with along with the IP packet, so that the switch knows like what like VLAN that you are carrying. And one more thing, right? So consider here, when I have a switches connected, the PC doesn't know about the VLAN. If question may ask, if you're fresher, right? The switch knows the PC knows about the VLAN? No. VLAN is only configured on the switches, so switches only knows like what VLAN and how to process this VLAN. The PC doesn't know what it belongs to. It just, for me, as well, it's a port that I connected. But all these VLAN functions and splitting the this different multiple broadcast domain, it's all done by the switches, and it's understandable by the switches only, not the end host. And let's see like how do we create a VLANs on a Cisco switch. And by default, if you create show VLAN brief on the Cisco switches, you can see like all the VLANs are mapped into VLAN 1, that is configured by default. So VLANs can be configured from global configuration mode, and you can assign VLANs names to VLANs while in VLAN sub configuration mode. So that will be doing it. And as you can see, by default, VLAN 1 will be configured when you have when you turn on your switch, all the ports will be in the VLAN 1, and you cannot delete the VLAN 1. And you can see like VLANs 1002 to 1005, and it cannot be deleted or it cannot be used. And as you can say active, but these are unsupported. So you can see this in any Cisco switches. The next will be the configuration. As I mentioned, you have to go into the configure the VLAN under the global mode, global configuration mode VLAN. Then under the sub level of the VLAN, you can you can mention the name of the each VLAN. What is the name? So for me, I created like clients and servers. I created two VLANs, and this is the output. When I give show VLAN brief, sorry, you can see that 10 is configured for clients and 20 is configured for server, but I didn't map any interface to this VLANs. Here you can see I didn't, still it is in the all the ports are belong to VLAN 1. The example I shown you only to create the VLAN. So you can you can map the VLAN under, if you go to that particular interface, and then you can map the VLAN over there. That this configuration tags will have a separate playlist will be coming in future, so that we'll be doing all this VLAN and configurations and everything. This is only for the theory purpose. Okay, now let's go through the show VLAN command. And show VLAN keywords provide the following benefits. So brief, when you give show VLAN brief, displays only the relevant port to VLAN mappings. When you give summary, it displays the count of VLANs and VLAN participating in whether VTP and VLAN that in extended VLAN range. So it gives the like full summary of the VLAN. Then you have an option called show VLAN ID. So then you can mention the VLAN ID that display the output of original command but filtered one. Basically, instead of show VLAN, you are giving show VLAN ID. It will only display the particular VLAN ID with the interface that map to that particular VLAN. Then you can also use this VLAN name also instead of VLAN ID. That also shows the same information as of VLAN ID. Okay, we discuss about the switches, we discuss about the broadcast domain, we discuss about the switch LAN MAC address, and here we will discuss about the switches ports, because ports in the switch are very important, right? Here comes, so there is something called access port. So access ports form the foundation of a managed switch. There are two types of switches. You have managed switches and a managed switch. Basically, we do all the configurations on the managed switch in the network. You have unmanaged switch also, but this course is mainly focused on the managed switch. So each access port is linked to a single VLAN only. So basically, if you have an access port, if you configure a port is connected to a PC, right? In the so if a switch, and if this port you can only it's about data, right? It's for you can configure only one VLAN. There is an option where you can where you have the like voice VLAN also. There is option in advanced switches where you can do the voice VLAN also. By default, it's mapped to the single VLAN that for data traffic. You cannot have like more than one VLAN for the data traffic or even for the voice traffic. So one VLAN per type of traffic that you are sending. And what it does is it transmits traffic from its assigned VLAN to the connected device and receive traffic from the device it forward to other device within the same VLAN. So what the statement says is if it is a VLAN 10, okay, and this is a VLAN VLAN 10. So when I send the receive traffic is only from the VLAN 1 within a switch, right? If this port is connected to VLAN 20, right? I won't receive the traffic that is belong to this port. If this port is sending any traffic, I will not receive it. I will only receive if any broadcast, any unknown unicast traffic is coming. So that I will receive only for the from the VLAN 10. So that's why we splitted this into different using VLAN. We split into multiple broadcast domain. So VLAN 10 is one broadcast domain. VLAN 20 is another broadcast domain. So whatever the traffic is sent by VLAN 10 will not be received in VLAN 20. We can say bump traffic, broadcast unicast and unknown unicast, right? So bump traffic will only receive per VLAN only. That port, where the device is connected and that configuration is configured on the switch. Next, on Castrol switch, ports operates at layer 2 by default. You can manually set the port as an access port using the command switch port mode access. So what you can do is you can by default, right? So it's all mapped into VLAN 1. So what you can do is you can map this port using go into that interface or whatever it is, right? It's interface FA0/1 and put like switch port access. You can create a switch port mode access, and so this command switch port. So which mode it going to be config switch port mode access. Then switch port access, and what is the VLAN that you are going to configure. VLAN 10, VLAN 20. You can use the VLAN name as also you can use the VLAN ID also. There are two options that you have. By default, people configure with the VLAN ID as a standard. So yeah, this is the configuration as I mentioned. So you have to do like what type of mode that the switches operates. Then you configure the VLAN under that particular interface. You can do like one by one interface, or here I have done like from 0/1 to 4. So it will apply to it's a range, actually interface range I've applied here, right? 0/1, 0/2, 0/3 till 0/4. There are 4 ports will apply to access VLAN 10. The same goes here 15, 16, 17, 18. Okay, so it considers 0/0/0/0/17, 0/18. So till this four ports will be configured for VLAN 20. Okay, we discussed about the trunk port where the end hosts are connected like servers and switches on a single switch, right? Consider in an enterprise network, you have more than, obviously you will have more than one switches, and you need to manage the traffic across, multiple VLANs between the switches. How do I do it? So that can be achieved through trunk ports. So this trunk ports is come into picture when you have like a switch is connected to another switch, or a switch is connected to a firewall, or a switch is connected to a router. That's where we configure the trunk port to carry the multiple VLANs from one switch to another device. It could be switch, router, or a firewall. So, so by default, trunk ports are capable of carrying traffic from multiple VLANs. So basically, when it exits in access port, the VLAN will be removed. If it is a trunk port, the VLAN will be encoded and then send it to the next device. That's the advantage of trunk port. They are commonly used to connect multiple VLANs between a switch, another switch, router, or firewall using a single port. By default on Catalyst switches, trunk ports are manually configured using the switch port mode trunk interface command. So earlier, how do we configure the access? We use the under the interface we went to switch port mode. There will be two options, trunk or access, and for the end host we used access. For switch to switch or switch to any external device that require that will where you need to carry the VLAN, so that will configure switch mode as a trunk. So this is the trunk port configuration. Hope you understand what is a trunk port and how do we do the perform the configuration. Yes, this is the output of show interface trunk. So we have configured two interfaces, gig 102 and 103, as per this, and this as a individual information from this output. I'm going to explain. The section one, you can see that it lists all the interface that are trunk ports, right? The status, association of whether it is a Ether channel. Ether channel we'll discuss later. Just know that association to an Ethernet channel and whether a VLAN is a native VLAN. Native VLAN will also be discussing in coming upcoming slides. Okay. So let's wait for that in few more minutes. In section 2, output displays a list of VLANs that are allotted into the trunk port. So as I mentioned, the trunk port carry multiple VLANs, right? So you can decide whether which VLAN can be carried or which can be removed or restricted also between the switches. So if you don't want, like consider I have two switches connected, but I don't want the particular server traffic to be sent to the next switch, right? So what I can do, I can restrict those VLANs, and then so the traffic will not send from this switch to the switch one to the switch two. So that can also be done. So that those things will be in the section 2. In section 3 displays where there is a forwarding state on a switch, right? Ports are in blocking state or not listed. So all the informations of the interface will be shown in the last section. Yes. We discussed about the allowed VLANs, which I mentioned. So the interface command switch port trunk allowed VLANs, VLAN ID, specify the VLANs that are allowed to transfer the link. Example configuration for limiting the VLAN that can cross gig 0/1 trunk port on VLAN 1, 10, 20, 30, 55 to 60. So which I told we can consider like I allowed a 2 VLAN, but I want to allow like VLAN 20 or VLAN 30, right? VLAN 55 to 60 extra, right? It will be easy for you guys if I draw a diagram, I hope. Switch 1, switch 2. So here I want to add the VLANs, VLAN 1, VLAN 2 already is allowed. VLAN 1 and 2 is allowed, okay? But I want to allow 20, 30, 55 to 60. This VLAN range I need to allow. How do I do that? Because I already did configuration. How do I extra add this? So there's a command for it. Also, how do, in case if I want to restrict the VLAN 20 and 30 not to be sent, how do I do it? That is also possible. So the command that I'll be showing it to you guys. So this is the command, and you can see that switch port trunk and switch port trunk, you can say like allowed VLAN 10, 20, 30, 55 and 60. Other than this particular VLAN, if it is I have the VLAN of 100 or 200 or 21, so those VLANs will not be allowed on the trunk port. Yes. So here you can see this is a, let's consider I have end host to just to refresh. This we as configured as access port, and switch to switch or switch to router or firewall. We configure this as a trunk because we want to carry the multiple VLAN information on the trunk port can be carried. So that has the um, eligibility or like mechanism that can carry the VLAN information from here to here. Okay, but access port no. When the switch sends the traffic, it will remove, it will take out the VLAN information and send only the traffic. But in case of trunk, it will add the VLAN information. It will not remove the VLAN ID when it's sending the traffic in trunk, unless it is a native VLAN. Okay. Let's discuss about the command. The full command syntax to configure the trunk allowed VLAN is switch port trunk allowed. You can do VLAN ID, or you can do all none all ID, or you can remove except. So there are a lot of other options that we have in a single command. So when you're doing in production network, make sure that you use the right command. Even if you execute a single command wrongly, like it will destroy the network. There'll be a huge issue will come. So make sure that whenever you execute the command, you are aware like what command that you are executing. So as I mentioned, so you can add the VLANs in case like I did a configure. Consider I did the configuration, right? Allowed VLAN now. I configure, but I want to add few more VLANs. How do I do that? So you should not do allowed VLAN. You should not do this because it will overwrite. For that, you need to add allowed VLAN. Then add this, right? Then switch port trunk. If you want to remove something, you can use a command remove those VLANs. So you always make sure that you use the right commands in the production network, or you do a testing to understand how it behaves. Because if you miss it, it will be a huge escalation coming to you. Okay, we discussed about access port, trunk port. I mentioned twice like there is something called native VLAN. So in the 802.1q standard, any traffic sent or received on a trunk port without .1q VLAN tag ID is assigned to the native VLAN. Consider as a traffic is by default in Cisco switches, the native VLAN ID is VLAN 1. Okay. For example, if switch has two access port configured for VLAN 20 and end host is connected to a trunk port with this native VLAN set to 20. Okay. Now the host will be able to communicate with the device on those access ports. Okay. So it is important to ensure that the native VLAN is consistent on both ends of a trunk line. Otherwise, traffic may unintentionally shift between the VLANs. So you always make sure when your two switches are connected, the native VLANs on both the switches are same. Okay. Otherwise, the different VLANs will be tagged on each end. Unless if there is a purpose or there is a intent to do it, you can do it. Otherwise, it's always recommend to maintain the same VLAN in both the switches as a same bit where the trunk is configured. So even if you misconfigure the native VLAN, but still the traffic will be delivered. But still, you will see an alarm that saying that native alarm mismatch. And this native VLAN configuration is per port basis using the interface command switch port trunk native VLAN ID. Okay, this is where was coming, so that it's easy for you to understand the native VLAN concept, right? So here I have VLAN 10, I have VLAN 20. Now my native VLAN here is 20. Okay, here also I configure native VLAN ID is 20. Okay, when the PC1 sends a traffic to PC2 between the switches, what it will do when the traffic hits, the switch will check what VLAN ID it belongs to. It belongs to VLAN 10, right? So what it will do in the packet, what it will do, it will add the VLAN ID of 10, and what is that? All the ports wherever the VLAN 10 is there, it will broadcast to all the ports, including the trunk port, except where it is received. Now, when it go to other ports here, then another consider here another PC is configured with VLAN 10. So it will remove the VLAN 10 and send only the IP packet. But in trunk port, what it will do, here you can say it will add the VLAN ID plus the Ethernet packet and pass it onto the another switch. So what happened for the native VLAN? So when the traffic comes from this port server, it is mapped to VLAN 20. So same process will happen. VLAN 20, wherever the VLAN 20 is there on the switch, it will send the traffic, and then it will also send the traffic to trunk port also. But here when sending it to the trunk port, because it's a native VLAN, so what it will do is it will not add the VLAN ID. Instead, it will send the without VLAN ID. So on the remote end, when the switch receive it, so it consider, okay, switch is coming with the packet, sorry, a packet is coming from the remote end without a VLAN tag, means I need to map that packet into my native VLAN ID, which is 20 here, and then it will deliver the packet here. So as you can see, end to end for native VLAN from one end to another switch, there's no VLAN tagging. The VLAN checks is only on this switch, and when it transfer, there is no VLAN ID. When it receives, here it will only check the VLAN ID and send it to all the ports that connect to that particular VLAN. But in case of other VLANs, which is not native VLANs, where you can see when it receives on the switch, it add the VLAN ID tag and then send it to the trunk and then to the remote chain. The same thing will happen here. And one more important point I want to give you tips is, right, these VLANs, right, will only be add or removed on the switches before sending in or sending out. Okay, this is how the native VLAN works. Let's see some outputs. So here I have given show interface gig 0/1 switch port. Okay, there is a switch in the switch first. When I see in like normal configuration, I can see that my trunk native VLAN mode, you can see VLAN 1 by default, right? After I reconfigured the VLAN 20, here you can see the trunk, right? Then the native VLAN is changed to 20. So you can use this particular command to see what is the what are the functions, whether it's a trunk and what is the my native VLAN, and everything will be seen from here. Even whatever the pruning or captures, so all informations that whatever here is here is seen here. Next thing is on switch, right? We are discussing about the switch. So in any switch, you have something called MAC address table, because when a hen host send a traffic from one port to another port host on the switch transfer, I mentioned that it has the ability to transfer it, not like a hub, right? So it has to save the layer 2 information somewhere where it saves. So it saves in the MAC address table. So the MAC address table keep the track of which switch ports and VLANs are associated with each device. And also a switch build this table by inspecting the source MAC address of the incoming traffic. This I already mentioned in the starting of the slide, that switch learn the MAC address of the any hen host from the only the incoming traffic, not the outgoing traffic. Okay, maintaining this information will help reduce the collision domain by limiting unknown unicast flooding, allowing for more efficient point-to-point communication between the device as well as the switches. So this is a mechanism that uses switch. This mechanism is not there in the hub. That's where it differs. So you can view the MAC address table using the show, as you can see, show MAC address table, address dynamic, or whether dynamic means it learned by the switch, or is there any static means there is an option called static where you can manually configure the MAC address. So that option is also available. So here you can see MAC address, dynamic or VLAN ID you can mention. These are the other options where you can see more information related to the MAC address table. Also, it specifies the timer also, how much time that it is spending. Because for a particular time, if there is no traffic between the hen host, it will remove it from this MAC address table. The next is the interface status. By default, in any switch you can see, or any router, you can see show interface status. It will show all the status. Let's go one by one. Port, here you can see there are like, here you can see, right? So what I'm going to do is in the show interface, I'll explain you what is port, name, status, VLAN, duplex, and speed type, right? First, port. The port displays the interface ID or the port channel, and next the name displays the configured interface description. So if you are configuring like it is connected to cube 13 cube 11f, right? So that when it's connected to the phone, or where it is connected, it's all connected to router, where in the upper it's connected to switches. So that information description will be under the name, and in the status which it displays whether the port is connected or it's not connected. So in this way, when you connect something, you'll know whether there's a faulty port or it's a faulty cable. You can identify it, and also the current status. Or you can do the sometimes, when you see disabled, it means that like there is something called error disable mode, or you can maybe by default you would have disabled that interface also, so the traffic will not be able to forward. That information can be seen in show interface in the status. Then you can see the VLAN, like whether it's a trunk port, whether it's a what VLAN it is configured. So those information can be seen on the VLAN. Then duplex. Duplex displays like a suffix, like you can say like it is auto negotiated duplex, or it's auto, right? It's a full duplex or it's auto negotiated can be seen. And speed, you can say it's auto speed, or what is the auto negotiated speed. Here you can see that. And type is whether what type of Ethernet is configured, right? 10, 100 BST or SFE plugin. So all the information can be seen in the type. So this information is useful when you are doing the first level troubleshooting. Next, let's see like how do we so far we have discussed about the access port, trunk port, native VLAN. How do we configure a access port, how do we configure a trunk, and also we did explore how do we limit the VLANs between the in the trunk port. So everything that we discussed, right? Next we'll discuss about how the forwarding data between VLANs will happen. Let's see, this is the topology that we will discuss between the how forwarding the VLAN, right? There are two primary methods for layer 3 forwarding. So forwarding traffic to devices within the same subnet or same VLAN. Here that discuss like consider it like I have the same sort of device where it's all belong to the same VLAN or the same subnet, right? The next will be forwarding device in different subnet. How do I consider like how do I let's consider I have a one subnet in 10.0, another subnet in 11.0. How do I send a traffic between different subnet? Or is it possible that I can switch traffic from VLAN 10 or VLAN 20? Okay, so how do I do that? This is in VLAN 10, right? VLAN 20. How do I achieve it? So that can be done. It's not that complex. So that information that we'll be discussing. And local network forwarding, right? So consider this topology. When two devices are in the same network, right, they communicate locally. As data is encapsulated with this IP address, the sending device recognize the destination is on the same network. They have the calculation, right? However, it still needs to add like layer 2 information and the layer 3 information then initially it does not know the MAC address of the destination. For that we do the ARP, so address resolution protocol, so that maps the layer 3 IP to the layer 2 by storing the IP address in the corresponding MAC address in the op table. On the switch on the router, if it supports, you can see show IP ARP, so you can see the mapping address of IP to MAC address. In your laptop, I think in the PC you can say put ARPA, ARP-A, so you will see the mapping of MAC address to IP address. Because it uses by default, this PC uses the ARP request to identify the remote end systems MAC address. So, okay, next routing between the VLANs. We discussed about the local, right? So local, right, when it uses the ARP address, so it's so basically here it uses the ARP request to identify the MAC address, and when it comes to switch, it's an unknown unicast flooding. So it will consider all belongs to same VLAN. So it send unicast flooding to all the switches that we discussed. Who are the destination? They will reply to the ARP request that will be delivered to PC1, and this PC to PC3 will be able to communicate. So that's within the same subnet or same VLAN. But what happened with the different VLAN? So we need a routing. So when it comes to different VLAN or different subnet, so we need a routing. So here you can say the enabling connectivity between two VLANs means enabling connectivity between two IP subnets. Therefore, we need to devise that act as a router. Because without router, you will not be able to switch traffic, because by default switch it's a layer 2 switch, so it will do only the layer 2 functionality. So you need the device that will do the layer 3 functionality to transfer the one subnet traffic to the other subnet. So that's where router comes into picture here. There are two possible solutions that we can use. The first is we can use the actual router to the routing. A switch itself can perform the routing functionalities. That's an advanced switches where they have the L3, they call it the L3 switches. They'll do the L2, also they'll do the L3 function. And switches that can perform layer 3 routing function called as layer 3 switch or multi-layer switches. Means multi-layer is by default switches layer 2. When it will be able to do the layer 3 also, they call this a multi-layer switches. So here you can see the first we'll discuss about how we use the router to send the traffic between the VLAN. So you can see this all part of one subnet and the right side is all part of another subnet servers. So what we'll do, we'll configure this VLAN 10 here, right? Here we'll configure VLAN 20. Okay, when the traffic want to send, so right, what is the by default we'll have like default gateway configured on the servers and default gateway configured on the router. So what all the traffic, if it is in different subnet, by default what it will do, it will send it to its default gateway. So my default gateway is my router. So by default, if it is another subnet, it will come to the router. Now the router will check the routing table, right, for the destination. It knows this is in the part of this particular interface, the destination is connected. It will send the traffic here, and then traffic will be delivered here. Same for here also, it wants to send, it will send it to the default. So basically it will send to the default gateway, sorry, default gateway. Then default gateway will check the routing table, and then it will send it to the destination. So this is what happens from the server. It will send it to the router, then again check the routing table. It will send it to the destination. Just quickly do the configuration for inter VLAN. So it's very easy, like you just go to the interface. So we have checked it, right? So what are the access VLAN and what are the server VLANs? So the same thing that we are configuring is VLAN 10 for access and VLAN 20 for the servers. And for the from the switch towards the router, we are configuring this to interface. One we put it in access VLAN 10, another interface we put it in access VLAN 20. So next thing what we will do on the router side, we will do the unshut, and then we will do the IP address configuration. So this IP should be the default gateway on your host, end host, whether it's a server, if it is PC. So whatever the IP is configured, VLAN 10, 192.168.1.1 will be the default gateway for PCs for the whole end host. For servers, it will be 10.1.0.1 will be the default gateway. Okay, so this is the router command show IP interface B, where you can see the two interface configured, and then you can see the route table. That's it all up. When you send the traffic, you don't have to do anything. It will done in a minute. Okay, there is one more method, right? So let's consider I have like hundreds of, like I have like tens of VLAN, right? VLAN 1, 2, 3, 4, 1 to 10 is there, 10, 20 to 100 is there, 10 VLANs are there. I don't want to waste like 10 interface on my switch and the 10 interface on the router, right? So how do I, what do I do, right? If I have switch, router, I need to use 10, if I have 10 VLAN, I need to use 10 default gateway, right? This is not a, best solution that you can do. There is some other solutions where it can utilize only one port, right? Or two ports maximum for the traffic to be sent from router to the switch and then back to the switch, because anyway the traffic will be switched within the switch only, right, or between the switches. So your router is not going to handle uh, like switch the traffic. We just have to switch the traffic. So I don't want to use the 10 links that will waste my switch ports or the router ports. For that, there is something called router sub interface, or you can call it as a router on a stick. So router on a stick is a technique to connect the router with a single physical link to a switch, and I perform the IP routing between the VLANs. Like I can ask, like, how do I do it? It's simple. You will create a trunk port, and then on the switch you allow the VLANs. On the remote end you will configure sub interface and match that VLAN over there on the router in a single port. Okay, that's what it says. From the switch perspective, this physical link is configured as a trunk port, allowing all the VLANs configured to be a routed. From the router perspective, the physical interface represents multiple virtual sub-interface, one for each VLAN. This router, this is the switch. Okay, here I configured multiple sub-interfaces here, and I configure the IP address over here. On this here, I will configure in the trunk port and allow the VLAN 10, 20, 30. Okay, in this way I will not waste my interface or the ports on the router or the switch. So an IP address from each VLAN is then configured on sub interface on the router, and then router will do the same IP, it will do the same routing lookup as it has done for the previous method. So this is the configuration on the switch. Sorry, this is the configuration on the router will do, and this is the show IP interface brief. You can see earlier it was like gig 0/0, gig 0/1, right? Instead now we have given the sub interface and then we have allocated the IP. Okay, this is a third method that we'll use, and the route there are two methods, two method we explored. And the third, there is something called switched virtual interface, like in Cisco it is a SVI interface we call it as. So there is something called layer 3 switch that has the IP routing process that can route packet based on the IP address information in the layer 3 header. So by default, mostly when we buy, right, it's a layer 2 switch, but you want to avoid this, creating multiple sub interface and configuring each and everything from switch to router. You want to avoid that. Then you go for the layer 3 switch. This means it checks the destination IP address in the each packet and decide where it sends, just like the router. So basically, when the traffic comes from to its default gateway, same like what router it does, it will do the routing lookup. Same thing, this layer 3 switch can do the routing lookup. So what they do is they utilize the hardware-based routing through ASIC, allowing them to route traffic much faster than traditional routers. That's a very big advantage, as if you use like layer 3 switches. An SVI in virtual interface, a virtual interface that associated with a VLAN. It functions like a router interface, providing IP gateway for the device within that VLAN. Earlier I mentioned server or the host will use the router interface as a default gateway, right? Now in this case, it will use the SVI, the layer 3 switch, multi-layer switch address as a default gateway for routing between the different VLANs to enable the routing, right? So basically, when you turn on a switch, it's all like switches means it's a layer 2 only, right? But you need to special functionality, a special command. You need to enable this to work as a layer 3. For that, there is a command called IP routing command. So you need to enable this command for the switch, layer 3 switch, to perform the routing. So the command is IP routing. Yes. Though we have already almost come to the section where first section of this playlist, and as we discussed, this is a topology. As you can see how the SVA works. So I created two SVA interface here, one for VLAN 10 and another one for VLAN 20. So here you can see when PC1 VLAN 10 want to communicate to VLAN 20, right? It doesn't need a router, right? It doesn't need, because I have an ability. I'll enable the IP routing here. I made it as layer 3 switch. But you cannot come and ask me, okay, the layer 3 2 switch can be converted to layer 3. No, it cannot. There is a specific product, layer 3 switches is there. So only those switches can act as a layer 3. Not layer 2 devices can, like, you cannot come and ask me, like, or you cannot assume that 2 9 series like switches can act as layer 3. No, it cannot. Right? There's an additional cost involved when you go for the layer 3 switches. So here, but you will have an, like, you avoid the router also. That's an advantage. So I create two SVA interface here, right? And when I send the traffic, what it do, it does not contain, it comes to this default gateway, and it does the like as usual default gateway. So as you can see, my default gateway is 192.168.1.1. So PC2 is sending the traffic to server 2. Okay. In this case, it knows that 192.168.1.11, 10.1.0.11, they are in different subnet. Okay. So when it knows that this both are in different subnet, so it has to send it to the default gateway. So it sent it to the default gateway. That is our SVA interface. Now it knows it can, the packet has came to the default gateway, so it has to do the routing lookup. So what it will do, it will check the routing, it will check the the destination IP, and destination IP is this, and it checks in the routing table. The routing tables points to the this SVA 20 interface that's belong to VLAN 20. Then the traffic will be sent here based on the ports. So that's how the SVA interface and the layer 3 switch works. Hope you guys like the video and it is helpful for you guys. If you like the video, share it with your friends, do a hit like button and subscribe to my channel. I know it's a very long video, but if you can like convert to like from speed 1 to 1.5x, you can finish the video possibly sooner. And thanks again for watching the video.